Okay, so lesson 4.6 is equilateral and isosceles triangles, and I know that we have already discussed what these two types of triangles are, but our main objective in this lesson is to be able to apply the properties of these triangles. So let's just briefly talk about the triangles here and the main properties that you're going to be utilizing. So isosceles triangle has two congruent sides, which we call those the legs. The side that is at the bottom of the triangle, we call that the base. Important information or property is that in an isosceles triangle, once we identify the bases, those bases are going to be the same measure. So they're going to be congruent. The other top angle, we call that the vertex angle. So main property that we're going to be utilizing is this concept that, number one, the two sides are the same and the two base angles are the same. Again, the base angles, you can always identify them by finding the angles opposite of your two legs. Okay, so that's our isosceles triangle. The other triangle that we're going to be utilizing today is the equilateral triangle, and we just did a warm-up problem with that. The other main property that is important with equilateral is to know that an equilateral triangle is always going to be equiangular, which means that all three of the angles in an equilateral triangle will always be 60 degrees. And again, that's a property that you're going to be utilizing in your algebra problems as we move forward in this lesson. Okay, we're going to do a few examples this morning that go along with these different triangles. The first one is an isosceles triangle example. And here's what it says. It says, find the value of x and y given the triangle. So the first thing that you would want to do is you'd want to identify, well, here are my two legs. So what that tells me is this is a base angle and this is a base angle. Well, the base angles in isosceles triangle are the same. We don't want to have two variables in our equation, so I'm just going to substitute and also call this x also. So if I do that, I can now say that x plus 62 is equal to 180 because we learned that all three angles add up to 180 degrees. We go through that process of solving. X plus x is 2x plus 62 equals 180. And if I subtract 62 from each side, I get 2x equals 180 minus 62 gives me 118. And if I divide by 2, x is going to be 59. And as we said before, x and y are both the same. So if x is 59, y is also 59. Okay, let's take a look at example 2. Example 2, you'll notice that we have three angles all marked as being the same. So that's an indication to us that this is an equilateral triangle. This problem is pretty similar to the problem we did in the warm-up, so why don't you take a minute and see if you can set this up and solve for the different values. Go ahead and go through the process. Again, a couple ways, more than one way you could set up your problem. I'm just going to go ahead and say 5x minus 9 is equal to 36. I'm sure some of you did 3x plus 9 equals 36. You could have done 5x minus 9 equals 3x plus 9. But if I add 9 to both sides, I get 5x equals 45. And if I divide by 5, I get x to be 9. So really filling in GE and EF should be pretty simple, because if this is 36, these should be 36 too. So I could just double check. 5 times 9 is 45, minus 9 is 36. So both of those would have to be 36. Any questions today with example 2? That was pretty similar to what we did on the warm-up. Let's go to example 3. Let's look at one where we're finding the angle values. Again, this is utilizing, again, our properties of our isosceles triangle. Notice in our picture here, we've got a triangle at the top that's isosceles and a triangle here that is isosceles. So when I'm solving this, you might think about where you can fill in values. So if this is 50 and this is x, this also has to be x. If you're thinking about your top triangle, this also would have to be y up here, because those angles are the same. So pretty similar to what we did in the first example, we can say that 50 plus x is equal to 180. If I go about solving that, 50 plus 2x is equal to 180. I subtract 50 from each side. So 2x is going to be equal to 130. I then divide that by 2. X is going to be 65. So there's my x value. Now, if I fill that in, I still need to use that to be able to find y. And here's how I'm going to do that. I know that these two angles here are supplementary. So if I do 180 minus 65, that gives me 115. So it tells me this angle up here is 115. And then I can go through that process one more time, like I did down here with the small triangle. I can say 115 plus y equals 180. So 115 plus 2y equals 180. If I subtract the 115, two y is going to be equal to 65. And then if I divide by 2, 65 divided by 2 is going to be 32 and a half. Now, I don't know how many of you remember, we talked about earlier in the chapter the exterior angle theorem. Another way you could have done this without setting up that kind of equation is, if we know this is 65, remember these two remote interior angles have to add up to that 65. So you could have also said 2y equals 65 to find that 32 and a half. And that might have been a quicker way to do that problem. Okay, I'm going to go ahead and take you through this one. So as I said, if you start with z, remember, think about that this triangle right here is equilateral. So that means that all three of these angles here have to be 60. So z is going to be 60. Now the next easiest one probably to fill in is y. Y is an an isosceles triangle, and these two angles are the base angles. Well, if this angle's 50, then this angle also has to be 50. So there's two of our values. Now, to find x, in order for us to find x, we do have to know this angle here in the triangle. Well, if this angle's 50 and this angle's 60, all three of these add up to 180. So 50 and 60 is 110. And if I take 180 and subtract 110, then that's going to tell me that that angle is 70. Well, again, this triangle here is isosceles, so if this is 70, this is 70. And then 70 and 70 is 140, so this angle here has to be 40. All three of those angles add up to 180. So 40, 50, and 60 would have been your three values there for that one. So on example 6, this is just kind of making sure we know the parts of our triangle. And we're going to do a little class participation on this one. So letter A says, name the side opposite of angle Y. Akira, can you tell us what the side opposite of angle Y would be? The side opposite of Y would be XZ. Very good. How about letter B? It says, name the side opposite of angle X. Okay, Austin said YZ, and that is correct. Letter C says, name the angle opposite of side XY. So for letter C, we're talking about angle Z. Letter D says, name the angle opposite of side YZ. Again, Bryce told us that it's angle X, would be opposite of YZ. Letter E says, XY and YZ include what angle? So we're talking about finding the included angle on this one. So the included angle here would be angle Y. And then the last one, XZ and YZ include what angle? So the included angle of XZ and YZ, the included angle would be angle Z. Okay.